Hi guys, this is O-level chemistry, paper 1, specimen 2023, question 21. The equation shows a reaction for the manufacture of ammonia. N2 gas plus 3H2 gas gives 2NH3 gas. This is the Haber's process. Which change will decrease the activation energy of this reaction? Okay. Option A, adding a catalyst. So what does a catalyst do to a reversible reaction? It speeds up the rate of reaction by lowering the requirement of activation energy. So this is supposed to be the correct option here. Let's see what the other options say. Option B, decreasing the temperature. Now, in order to understand the effect of temperature on an equilibrium, we need to know whether the forward reaction is endothermic or exothermic. Since this is the Haber's process, it is an exothermic reaction. So for an exothermic reaction, the option is saying decreasing the temperature. A decrease in temperature favors the exothermic side of the reaction, which means the reaction would move in the forward direction, but it will have no effect on the activation energy. So option B is incorrect. Option C, increasing the concentration. Now, the effect of concentration is such that if you increase the concentration of reactants, the forward reaction is favored, and if you increase the concentration of products, the backward reaction would be favored. However, in either case, there would be no effect on the activation energy with respect to increasing or decreasing the concentration. So, option C is also incorrect. Option D, increasing the pressure. So for an equilibrium, an increase in pressure favors the side with the lesser number of moles. If you look at this equilibrium, there are 4 moles of reactants and 2 moles of products. So if the pressure is increased, the forward reaction would be favored. However, favoring the forward reaction will have no effect on the activation energy for this reaction. So eliminating options B, C, and D, option A is the correct option for this question. Question 22. In this question, it says a reversible reaction is shown. Which changes increases the mass of the precipitate formed? So in this equilibrium, there is 1 mole of BiCl3 aqueous along with 1 mole of water liquid. And on the product side, we have got BiOCl as a solid and 2 moles of HCl aqueous as liquid. So, which changes increase the mass of the precipitate formed? The precipitate formed is on the product side. So now let's consider the options. Option 1, adding more water. If you add more water, so you increase the concentration of the reactants, which would result in the equilibrium being favored in the forward direction. And when the equilibrium is favored in the forward direction, the mass of the precipitate would increase. So adding more water is a correct option. Option 2, adding aqueous sodium hydroxide. Sodium hydroxide is a base. Sodium hydroxide would react with the acid present in the solution and it would convert it into salt and water. Now, what will happen is the quantity of HCl present would decrease. If the quantity of HCl present decreases, then the equilibrium is favored in the forward direction to increase the quantity of HCl. And as a result, if the concentration of HCl increases, the mass of precipitate will also increase, making option 2 a correct option as well. Option 3, adding dilute HCl. If you increase the concentration of HCl, then the reaction would be favored in the backward direction. And if the reaction is favored in the backward direction, then the precipitate that is present in the products is used up, so its concentration decreases. And when its concentration decreases, that means its mass decreases, which means that option 3 is incorrect. So as a result, our correct options are options 1 and 2. And for this question, option A is the correct answer. Question 23. Sulfur trioxide is produced by the reversible reaction shown. 2SO2 gas plus O2 gas gives 2SO3 gas, and this has an enthalpy change of negative 195 kilojoules per mole, which means it is an exothermic reaction. Which change in conditions will produce a greater amount of SO3 at equilibrium? That means we need to favor the reaction in the forward direction. So adding a catalyst will not change the yield of the product. Adding a catalyst will only speed up the rate of reaction. So adding a catalyst will not have any effect on the amount of SO3 at equilibrium. Option B, increasing the pressure. Increasing the pressure favors the side of the equilibrium with the lesser number of moles. Number of moles of reactants are 3, number of moles of products are 2. So increasing the pressure will shift the equilibrium in the forward direction. And if the equilibrium shifts in the forward direction, the amount of SO3 present at equilibrium would increase. Option B is correct. Option C, increasing the temperature. Increase in temperature favors the endothermic side of the reaction. Since this reaction is exothermic, an increase in temperature will shift the equilibrium in the backward direction, which would decrease the amount of SO3 present at equilibrium. Thus, option C is incorrect. Option D, removing SO2 and O2. SO2 and O2 are both reactants. If you remove SO2 and O2, you are basically decreasing the concentration of the reactants. If the concentration of the reactant is decreased, automatically the concentration of the product increases. And when the concentration of the product increases, the equilibrium will shift towards the left so that the concentration of the reactants can be restored. And since the reaction moves towards the left, the amount of SO3 present at equilibrium would decrease, making this an incorrect option. So for this question, option B is the correct option. Question 24. Iron 2 ions react with chlorine. And now the equation given here is a redox equation. So let's see what is happening. Iron 2 is being converted into iron 3, which means iron 2 is being oxidized. And chlorine as a gas has an oxidation number of 0. Chlorine is being converted into chloride ions, which has a oxidation state of -1, which means it is undergoing reduction. So the question asks, which statement about this reaction is correct? Chlorine is reduced by iron 2 ions. Iron 2 ions are being oxidized, chlorine is being reduced. This is the correct answer. Next, option B, chlorine is the reducing agent. Chlorine itself is undergoing reduction. A reducing agent reduces the other species present and itself gets oxidized. Since chlorine itself is getting reduced, it is an oxidizing agent, not a reducing agent. Option C, iron 2 ions are reduced by chlorine. Change in oxidation number is from +2 to +3. That means loss of electrons are taking place, which means iron 2 ions are being oxidized by chlorine. Option D, iron 2 ions are the oxidizing agent. If iron 2 ions were the oxidizing agent, they themselves would have undergone reduction. Since they are undergoing oxidation, it means that iron 2 ions are acting as reducing agents, not oxidizing agents. So this is also incorrect. As a result, option A is the correct option for this question. Question 25. Which reaction involves reduction and oxidation? Okay, first one. Chlorine gas reacting with aqueous potassium iodide. So this reaction would be Cl2 gas reacting with potassium iodide, 2 moles of Ki aqueous. This will produce 2 moles of KCl aqueous and I2 aqueous. So in this case, we have chlorine having an oxidation number of 0 being converted into chloride ions having an oxidation number of -1. Therefore, chlorine is undergoing reduction. And we have iodide ions having an oxidation state of -1, being oxidized to iodine having an oxidation number of 0, which means this is a redox reaction as asked in the question. So option 1 is correct. Moving on to option 2, we have dilute sulfuric acid reacting with magnesium. So we have sulfuric acid H2SO4 aqueous reacting with magnesium metal Mg solid. This will produce magnesium sulfate solution and it will liberate hydrogen gas. So in this case, we have magnesium with a charge of 0 being converted into magnesium sulfate, in which the magnesium ions have a charge of +2. So magnesium is being oxidized, whereas in sulfuric acid, hydrogen ions have a charge of +1 and they are being converted into hydrogen gas which have a charge of 0. So +1 to 0 is reduction, which means reaction 2 is also a redox reaction as asked in the question. Moving on to the third option, dilute HCl reacting with aqueous sodium hydroxide. We have HCl, we have NaOH. This is a reaction between an acid and a base. An acid and a base result in the formation of a salt and water. So in the case of hydrogen, hydrogen has a charge of +1 in HCl and a charge of +1 in water. So it is not undergoing oxidation or reduction. Chloride ion has a charge of -1 in the molecule of HCl and in the molecule of NaCl as well. So it is not undergoing oxidation or reduction as well. Sodium has a charge of +1 in NaOH and a charge of +1 in NaCl. So oxidation reduction is not taking place. And oxygen in NaOH has a charge of -2, whereas in water also it has a charge of -2. So none of the elements present have any change in their oxidation number. That means this is not a redox reaction. So the third option given is not a redox reaction because no oxidation and reduction is taking place. So as a result, options 1 and 2 are correct, which makes option B the correct answer for this question. Question 26. Which statement about weak acid is correct? They are partially dissociated in aqueous solution. This is the definition of a weak acid. So option A is definitely correct since it defines what a weak acid is. Option B, they do not react with alkalis. An acid, whether it is strong or weak, will react with alkalis. So option B is incorrect. They do not react with metals. Acid, whether it is strong or weak, will react with metals. So metals that are more reactive than hydrogen. So they do not mention which metal is being used here. So we will consider in general metals that are more reactive than hydrogen. So even weak acids would react with them. So option C is incorrect. Option D, they form solutions with pH values in the range of 0 to 2. No, 0 to 2 is the pH range for strong acids. Since they're talking about weak acids will have a pH greater than 3 and less than 7. So this is the range for the pH of a weak acid. What option D is describing is the pH range of a strong acid. So option D is incorrect. So based on our choices, option A is the correct option for this question. Question 27. A colorless aqueous solution of pH 13 is tested separately with methyl orange indicator and thymophthalene indicator. Which row is correct? So in order to answer this question, we need to know that methyl orange under acidic conditions appears red in color and under alkaline conditions appears yellow in color. This is something we need to remember. Similarly, thymophthalene under acidic condition appears colorless, and under alkaline conditions appears blue. So if we remember this, then we can easily select the correct option. So if the pH of 13 is given in the question, that means alkaline conditions are considered. So methyl orange must appear yellow and thymophthalein must appear blue. So methyl orange yellow, options C and D, and thymophthalein is blue in option C, making option C the correct option for this question. Question 28. Which pair of reagents is suitable for preparing a pure sample of copper 2 chloride crystals? Now, since we are preparing copper 2 chloride crystals and copper chloride is a soluble salt, so the reaction that we need to consider is the reaction of an insoluble oxide or hydroxide or carbonate of copper with an acid. So, option A says aqueous copper 2 nitrate, which is soluble, and aqueous sodium chloride, which is also soluble. So these will not react and produce copper chloride. So option A is incorrect. Option B, copper and aqueous sodium chloride. Copper is a metal, sodium chloride is a salt. Copper will not react with a neutral salt. So option B is incorrect. Option C, copper and dilute hydrochloric acid. This is a reaction between a metal and an acid. If copper would have been more reactive than hydrogen, then this reaction would have taken place. But since copper is less reactive than hydrogen, copper will not react with dilute hydrochloric acid. So this reaction will not take place as well. Option D, copper 2 oxide. Copper 2 oxide is CuO, which is insoluble. When it reacts with dilute HCl is aqueous. So the insoluble salt would react with the acid, producing a soluble salt, CuCl2 aqueous, and it would produce water. And once this has been produced, the copper chloride can be crystallized using the process of crystallization by heating it and evaporating the water present. So option D has the correct answer for the preparation of copper 2 chlorides, making option D the correct option for this question. Question 29. Element X forms an oxide of the formula X2O5. In which group of the periodic table is X likely to be found? We can find this out by finding the oxidation state of X. So X2O5, we have got 5 oxide ions. So 5 oxide ions, each oxide ion has a charge of -2. So 5 oxide ions will have a net charge of -10, which will be balanced by the net charge of +10 on all the atoms of X present. Since there are 2 atoms of X present, we have +10 divided by 2, giving us +5 as the oxidation state of X. If X has an oxidation state of +5, it means X has lost 5 electrons, which also means 5 electrons were present in the outermost shell of X. Thus, X belongs to group 5, making option C the correct option for this question. Question 30. The diagram shows the structure of an alloy. Which statement about alloys is correct? Alloys can only be formed by mixing copper or iron with other metals. No, they can be a mixture of metals along with non-metals. So option A is incorrect. Option B, carbon and iron are the only two elements in stainless steel. No, stainless steel also contains some quantities of sulfur, phosphorus, and other elements. So option B is incorrect. Option C, in an alloy, there is attraction between positive ions and a sea of delocalized electrons. Alloys are metals. So metals do have an attraction between positive ions and a sea of delocalized electrons, which is known as the metallic bond. So alloys being metals will have the same attraction. So option C is correct. Option D, the alloy brass has a chemical formula. Brass is an alloy of copper and zinc, but it does not have a chemical formula. It is just a mixture of these two metals. So option D is incorrect. Thus, for this question, option C is the correct answer.